Hey guys, welcome back to geometry. Last time we were together, we were looking at conditional statements, and a conditional statement is written as P arrow Q, and we read it if P then Q, or P implies Q. Now we're going to take another look at these today, but we're going to add some other statements that are based on that original conditional statement. And the ones that are based on that original conditional statement are called related conditionals. Okay, so they're not exactly if P then Q. The conditional is the original, okay, and that's if P then Q. So for example here, we have if you work hard, then you will be successful. Okay, and this is your basic statement. Now the converse. For the converse, we're going to reverse the order. So instead of P implies Q, we're going to have Q implies P. So if we flip that around, instead of if you work hard, then you will be successful, we're going to switch those. Okay, and we're going to have if you are successful, then you work hard. Okay, now this first one seems pretty true. If you work hard, you'll be successful. If you're successful, then you worked hard. This one's not necessarily true. Maybe you just got lucky. Okay, but we'll talk about that a little bit more later on. Okay, next up, we have the inverse. Okay, the inverse, instead of reversing them, we're just going to take that original conditional and we're going to negate both. So we'll say if not P, then not Q. Okay, so instead of flipping these around, we go back to the original. So if you work hard, the negation of that would be if you don't work hard, okay, then you'll be successful. The negation of that would be then you will not be successful. Okay, and then finally we have the contrapositive. Contrapositive is all kinds of mixed up. We negate both and we reverse them. So if not Q, then not P. So we flip this around. First off, we flip it around and we make it negative. So if you are not successful, then you did not work hard. Okay? So the conditional is the original, if P then Q. Converse, we reverse the order. Inverse, we negate both. Contrapositive, we negate and we reverse. Now, let's take a look at the truth tables for each of these. So first off, let's look at the original, if P then Q. All right, so we said last time that the only way conditional statements are false is if the hypothesis is true and the negation is, if the hypothesis is true and the conclusion is false. Otherwise, it's always going to be true. So let's look at this again. I have true, true, then that means that the conditional is also true. Okay, I have true, false. This is the scenario where where the conditional is going to be false. The hypothesis is true and the conclusion is false. Okay, then I have false, true. Okay, this one, the hypothesis is false, but the conclusion is true. That means the conditional is true. And then lastly, we have false, false. The hypothesis is false, the conclusion is false, but the conditional is true. Okay, so this is our original. This is our base right here. Now for the next one, we flip the order around. We say if Q, then P. Well, it follows all the same rules. Okay, the only way that this conditional can be false is if the hypothesis is true and the conclusion is false. So we're going to look at these same two columns in the truth table, but we're going to flip the order. So first we look at Q, then we look at P. So I have if Q, then P. The hypothesis is true. The conclusion is also true. That means that the entire conditional is true. Okay, then I look at Q, then P. Well, the hypothesis is false, and if the hypothesis is false, it doesn't matter what the conclusion is, because the entire statement is going to be true. Okay, then I look at the hypothesis being true and the conclusion being false. This is the scenario where the entire conditional is false. Okay, and then we have the hypothesis is false, and if the hypothesis is false, it does not matter what happens with the conclusion. If the hypothesis is false, then the entire conditional is false. So what we can see here is that the original, the conditional statement, and the converse do not necessarily all have the same truth values. We're going to come back to that a little bit later on. Okay, now the next one is the inverse. So on the inverse, we look back at the original P and Q. Okay, and we put them back in order, but we take the negation of both. Well, if we're going to take the negation of both, we're going to need to write those columns into this proof. So not P has all of the opposite values of P. So the first two are true, the second two are false. That means the first two are going to be false, and the second two are going to be true. Okay, and the negation of Q is going to have all of the opposite values of Q. So if Q is true, not Q is false. If Q is false, not Q is true. If Q is true, not Q is false. And if Q is false, not Q is true. Okay, now we're going to take a look at these two columns and use them to inform this column here. Now the rules are still the same. The only way that this conditional, even though it is the inverse, the only way that this column can be false is if the hypothesis is false, the hypothesis is true and the conclusion is false. So we're going to take a look at the not P column. Okay, and the first two rows of the not P column are false. So in this case, our hypothesis is false. It doesn't matter what the conclusion is. The entire statement's going to be true. Okay, then the next one, same thing. Your hypothesis is false. It doesn't matter what the conclusion is. The entire statement is going to be true. Okay, now on the next two, we have the hypothesis is true. Now the only way that the conditional statement can be false is if the hypothesis is true and the conclusion is false. And that happens in this row. So this time, the inverse is going to be false. Okay, now over here, we have that the hypothesis is true, the conclusion is true. That means that the entire statement is true. Okay? All right, and then lastly, we have the contrapositive. And with the contrapositive, we negate both statements and we reverse the order. So instead of the original if P then Q, we have if not Q, then not P. All right, so this one's all kinds of jumbled up. So we're going to look at these two columns, okay, not P and not Q. The not Q is going to be our hypothesis, and the not P is going to be our conclusion. So if not Q, then not P. So not Q is false. If the hypothesis is false, that means that the entire statement is going to be true. Okay, then next one. If not Q, then not P. Well, the not Q, the hypothesis is true, and the conclusion is false. This is the scenario where the entire statement ends up being false. Okay, then the next one. If not Q, then not P. We have the original statement is false, and the hypothesis, the hypothesis is false, the conclusion is true. That makes the entire conditional true. And then lastly, we look at the scenario where not Q is true and not P is true. That means that that contrapositive is going to be true. Cool. So we filled in this whole truth table here, okay, for all of these different scenarios. Now, this is just, it's not one question. We have it, just all of these different scenarios put into the same truth table. So for if P then Q, true, false, true. Oops, sorry, this one here should also be true. Sorry about that. So we have true, false, true, true. For the inverse, we have true, true, false, true. For the, sorry, that was the converse. The converse is true, true, false, true. But the inverse is also true, true, false, true. And then the contrapositive is true, false, true, true. So take a look at those columns, and let's compare those to one another. Okay, the conditional and the converse. So the first one, the conditional is this one, and the converse is this one. Okay, now we can see that the conditional and the converse do not necessarily all have the same truth values. Okay, but the conditional and the inverse. Okay, let's look at those two. So we have the conditional is here, and we have the inverse is this guy. Okay, well, these truth values also don't match up. They do not always have the same truth value. Some of them are true or match up, but not all of them. Okay, but the conditional and the contrapositive, okay, this is where we notice something. True, false, true, true. True, false, true, true. These two statements are always going to have the same truth value. So no matter what P and Q are, if P then Q, and if not Q then P, the original conditional and the contrapositive will always have the same truth values. Okay. Now also take a look at the inverse. Oop, that's this one. And the converse, that's this one. True, true, false, true. True, true, false, true. The converse and the inverse always have the same truth values as well. So it won't matter what Q and P are. In the inverse and converse of an original conditional will always have the same truth values. Now, statements that always have the same truth values are said to be logically equivalent. So if I say, we take our original examples up here. If you work hard, then you will be successful. If you are not successful, then you didn't work hard. These two statements are said to be logically equivalent because no matter, the truth values of the first one will always be the same for the second one. And they're basically saying the exact same thing. If you work hard, you'll be successful. If you're not successful, that means you didn't work hard. Okay, now let's take a look at some examples here, some practical examples, and let's write the conditional, converse, inverse, and contrapositive of the statement and determine whether each statement is true or false. If the statement's false, give a counterexample. So the original statement is linear pairs of angles are supplementary. So if a pair of angles is a linear pair, then the angles are supplementary. Okay? If a pair of angles is a linear pair, then the angles are supplementary. Well, that's part of the definition of a linear pair, is that they are adjacent and they are supplementary. So this statement is true. Okay, the converse. Now the converse is the one where we switch the order. So we'll flip this around and we'll say if two angles are supplementary, then they are a linear pair. Okay, well, this one is not necessarily true. Okay, there are instances where this is false. Okay, for instance, here's our counterexample. Okay, here's one angle. And let's say here is another angle. And let's say this one is, I don't know, looks about 40 degrees to me. That looks like 400. Let's just use the text. Oop. 40 degrees. And let's say this angle is 140 degrees. Okay, those two angles are supplementary. They add up to 180 degrees, but they're not a linear pair. They're not adjacent. Okay, so all we need is one counterexample, and then the whole statement can't necessarily be true. Okay, the inverse. If a pair of angles is a linear pair, then the angles are supplementary. The inverse is the one where we negate both of them. So we say if a pair of angles is not a linear pair, then the angles are not supplementary. Okay, so what this is saying is that angles have to be a linear pair in order to be supplementary. And that's not necessarily true. Okay, I can definitely look at this same example that we just talked about for both of these. Okay, this is not a linear pair. Okay, but those angles are definitely supplementary. So this pair of angles works for both the converse and the inverse of that original statement. Okay, then we come back to the contrapositive. Okay, and I should say that this is false here. Okay, the contrapositive, we take the original statement, we reverse the order, and we negate both. Okay, so we can say if a pair of angles is not supplementary, then it is not a linear pair. Well, part of the definition of a linear pair is that they have to be supplementary. So if they're not supplementary, they can't be a linear pair. So this one is true. And let's make each of these be consistent here. There we go. Okay, so since it's true, I don't need a counterexample. Now what we'll notice, guys, is that the conditional statement and the contrapositive are always going to have the same truth value. And the converse and the inverse are always going to have the same truth value. If it doesn't work out that way, that would indicate that something went wrong. Okay, now let's take a look at just a couple more. Okay, example 2, write the converse, inverse, and contrapositive of the given conditional. Determine whether if each statement is true or false. If it's false, give a counterexample. So the conditional statement this time is given to us. If aliens have visited Earth, then there is life on other planets. So we have right here we have our hypothesis, and right here we have our conclusion. Okay, so for the converse, we need to reverse those around. Okay, now the converse would be if there is life on other planets, then aliens have visited Earth. And we want to determine the truth value of this statement. Well, does this have to be true? If there's life on other planets, do the aliens have to have visited Earth? Well, no, that doesn't necessarily have to be true. That could be false. A little glitch right here. Here we go. Okay, aliens might live on another planet, but have not visited Earth. Okay, and that's very possible that there could be life on other planets and we just don't know about it yet. Okay, maybe they haven't created space travel. Maybe they're not even interested in Earth at all. Okay, so it's totally possible that aliens could live on another planet and have not visited Earth. Okay, now the inverse. So we take that original statement, and the inverse, we negate both of the original statements. So if aliens have not visited Earth, then there is no life on other planets. Okay, and this is suggesting that if they have not visited Earth, then there can't be life on other planets. They're saying that if there's life, it has to have visited Earth. And that's not necessarily true, okay, for the same reason as above. Maybe aliens live on a distant planet and have not visited Earth. Okay, it's entirely possible. They haven't visited Earth, okay, but they're still on another planet. It's totally possible. Okay, then lastly, we have the contrapositive. Okay, in the contrapositive, we take the original conditional statement, okay, we negate both, and we reverse them. So we say, if there is no life on other planets, then aliens have not visited Earth. Okay, and this one actually checks out. Okay, if there's no life on other planets, then there can't be aliens to visit Earth. So this one would absolutely be true. So once again, we notice that the contrapositive and the conditional statement must have the same truth value. Oh, we didn't put the truth value here. If aliens have visited Earth, then there is life on other planets. Well, yeah, if they visited Earth, then they must have come from another planet. Okay, so this one is true. So again, we notice that the original conditional and the contrapositive have the same truth value, and the converse and the inverse have the same truth value as one another. Okay, let's take a look at one more. Okay, we have same description, okay, but this time the statement is a triangle has 3 sides. Okay, so we want to write the conditional statement. If a polygon is a triangle, so if it is a triangle, then it has 3 sides. Okay, well, that's absolutely right. If it's triangle, then it has 3 sides. That's part of the definition of a triangle. So this one is true. Okay, the converse. Okay, the converse would be, we've reversed the order, so if a polygon has 3 sides, then it is a triangle. Well, if a shape has 3 sides, everyone in this class knows that it's going to be a triangle. That's true. It could be lots of different types of triangles, but if it has 3 sides, then it's a triangle. Okay, then the inverse. The inverse, we take that original if P then Q statement, the original conditional, and we just negate both of the components, both P and Q. So we say if a polygon is not a triangle, then it does not have 3 sides. Okay, so a polygon does not have 3 sides. So if it has 4 sides, definitely not a triangle. If it has 5 sides, still not a triangle. If it has any number of sides other than 3, it's not a triangle. So if it's not a triangle, it can have any number of sides other than 3. So this statement is also true. And then lastly, we have the contrapositive. Now the contrapositive, we take that original conditional, we negate both halves of the statement, and we reverse it. So we say if a polygon does not have 3 sides, then it is not a triangle. Okay, now, so if it does not have 3 sides, then it's not a triangle. So if it has, this is just like the last one, if we say it has more than 3 sides, any number other than 3 sides, it's not a triangle. This statement's always going to be true. So in the last 2 examples, we had true, false, false, true, okay, for the conditional, converse, inverse, and contrapositive, respectively. But that's not always going to be the case. There are instances where the conditional, the converse, inverse, and contrapositive can all have the same truth value. But what's important is that the conditional and the contrapositive have to have the same truth value, and the converse and the inverse have to have the same truth value. It's possible that they could all 4 have the same truth value, but those pairs have to match up. Okay, so let's summarize here. Okay, first off, the conditional statement. Okay, the conditional is the original, okay, and that's if P, then Q. The converse, we reverse those, so that would be if Q, then P. The inverse, we negate both. So that would be if not P, then not Q. And the contrapositive, we negate and reverse. So that's if not Q, then not P. And we said that the conditional and the contrapositive are logically equivalent. They have all the same truth values. And the converse and the inverse are going to be logically equivalent because they have all of the same truth value.